This statement here at the end that says that negative 1 is a 0 of this function means that if I were to replace x with negative 1, I would get 0. And so based on the remainder theorem, that tells me that if I put a negative 1 in the box of the synthetic division, that my remainder is going to be 0. Putting a negative 1 in that box would be like dividing that polynomial by x plus 1. And having a remainder of 0 is telling me that x plus 1 then would divide in there evenly. Or another way to say that is I could factor my original polynomial and it would have a factor of x plus 1. And so we're going to go ahead and carry out this synthetic division so that we can see what that quotient is and maybe be able to continue to factor it to get our other solutions. So let's go ahead and set up our synthetic division. So we have a 15, 14, negative 3, negative 2. Now based on the given information, I am expecting this remainder to be 0. So if it's not, that probably means I made some kind of mistake there in the division. As we bring our first number here straight down and multiply by negative 1, so that's negative 15. And add, so that's negative 1 times negative 1 is positive 1. Add, that's negative 2 times negative 1 is positive 2, and add, and that's 0. So there's our remainder of 0 that we were expecting. So basically what we have just done is we have factored that 15x cubed plus 14x squared minus 3x minus 2. So I'm going to go ahead and write out the factorization so we can kind of see what exactly we're doing, even though we wouldn't necessarily need to take all these steps in the process of solving this. I'll go ahead and write out the factored form. And so if we look over here toward the right, we are ultimately trying to solve this equation. We have just essentially determined that x plus 1 is a factor divided in there evenly. Now it would be x plus 1 times whatever we got when we divided out the x plus 1, which would be our quotient down here. So that's a 15x squared minus 1x minus 2. So we could verify this by multiplying it back in and we should get our original polynomial. So this original polynomial is going to have three solutions. One of them, it told us, one of them is x equals negative 1. That would come from setting this factor equal to 0. The other two solutions are going to come from setting this factor equal to 0. And so we may be able to solve that by continuing to factor, or we may need to use the quadratic formula. But let's go ahead and set that one up separately and set it equal to 0. So this particular polynomial can be factored. We would use a 5x and a 3x for 15x squared. And putting a minus 2 here and a plus 1 here would make it so when we did our outer terms we'd get plus 5x and the inner terms would be minus 6x, and that would add up to minus x. So now we go ahead and take each of those two factors and set them equal to 0 separately and solve each of those two for x. So this would give us our remaining two solutions. X equals 2/5. And we're going to get from this one here, x equals negative 1/3. And so our three solutions to that original equation are x equals negative 1. That was given to us. X equals 2/5, or x equals negative 1/3.